last presenter of this series is Dr. Nicole Rogers. She is Assistant Professor of Silviculture at the University of Maine, Overall.
Okay, great. Thank you, everyone. I'm really happy and maybe concerned to be wrapping up this session. Some of the themes we've been hearing already will be presented here again, and they can feel overwhelming, perhaps, say if you're trying to regenerate sugar maple. But I think there are also some silver linings here that I'd like to share with you today. I'd like to start by thanking my co-authors on this work, Tony D'Amato, Ralph Nyland, Bill Leake, and Mark Twery. A quick overview, I'll discuss the northern hardwood forests. We've obviously heard a lot about these in the last couple of days, so I promise to be short and sweet here, but I do want to make sure and emphasize the long history we have in these forest types of integrating site considerations into our silviculture decision-making. I also want to introduce the long-term studies that we're using for this work, including our research objectives and results, and then wrap up with some management implications. And so when we're talking about the northern hardwoods, these are really diverse forests. That's not news to anyone here, I suspect. It covers a really broad geographic range. If we're looking at this image on the right-hand side of the screen, it's that maple beech birch forest type in blue, and you'll notice that it interfaces with a lot of other forest types as well. For example, spruce fir as we get to the northern latitudes, some of our southern hardwoods as we move into southern New England and New York, and visually just really distinct from place to place. So all four of these images come from across the northern hardwood forests in the Northeast. They look really distinct in terms of the species that are present and the diameter classes that are there. And what's driving that distinction, what's creating that variability, a long list of things. So it could be past management, land use history, ownership objectives, native and non-native, invasive, non-native, insect and disease outbreaks and other disturbance regimes, and then of course our site characteristics. So things like climate, soil productivity, soil moisture, browsing agents, et cetera. And that's really where I want to key in today. And these distinctions within the northern hardwood forest, I think we can all probably visualize in our mind. And if you couldn't before this conference, you've probably seen quite a few photos that look like this. So there are places within this forest where it feels like no matter what we do, it's always going to come back to a beech thicket. And then maybe if you're from the Lake States or Western Canada, I've heard of this phenomena called mapleization. We don't really have that here, but I have seen some really nice sugar maple stands where it almost seems like I don't need to be there at all. That forest wants to grow sugar maple. And part of what's going on there is this matching of our management with our site. And of course, we see these trends evidenced in the data too. So this is a hotspot analysis using Forest Service FIA data. And to be frank, I could probably stop my presentation right after this slide, but that would leave a lot of time, so I'm going to keep going. What we're looking at here is established sugar maple regeneration on the left, and then established American beech regeneration on the right. So I'm talking about, stems about this high all the way up to our larger sapling size classes. The red dots represent places where we have statistically high amounts of sugar maple on the left, or statistically high amounts of beech on the right, and then the cold spots are where those species are in lower abundance. And what you'll notice is that there isn't an overlap in those hotspots. Where sugar maple is really high in abundance, American beech isn't, and vice versa. And so that's something to keep in mind, again, as we're thinking about our options for managing not only these species, but the more complex northern hardwoods as a whole. And of course, that's where this idea of site and silviculture come in. And this is not new. We see this reflected in our early textbooks, like the work by James Toomey, our foundational literature specific to the northern hardwoods. And then for the folks who try and write broad regional silviculture guides, they're pulling this all together, and that's no small feat, like the guide published by Bill Leake and Mariko Yamasaki and others from the Bartlett Experimental Forest. And Bill was really one of the biggest advocates for this idea early on in New England and more broadly. And he published quite a few great papers on this, but I really love this particular table that comes from his 1987 publication. And what Bill is looking at, let's see if I can do this. We've got habitat here on the left, so you can think about this as site. At the top, more productive sites, and as you move down the list, lower productive sites. He then provides the climaxed species that you would associate with those habitats, the successional species, and what I really like is then he goes on to recommend different silvicultural systems that could be associated with those habitats. I think this provides a great framework when we're thinking about the complexity of northern hardwoods and what our options might be. So we wanted to dive into that a little more. When I say single tree selection, I'm sure it looks different to every person in this room. Or when I say uniform shelterwood, how we would envision that being laid out can look different from person to person. And we wanted to see how it looks in different silviculture studies over time. So we're looking at even and uneven age treatments. They range in time from 20 to 80 years. And the three that I'm going to be talking about today are Huntington Wildlife Forest, which you see on the map here. It's in the high peaks of the Adirondacks. This was overseen by Ralph Nyland for the duration of his career. Up next is the Forest Ecosystem Research Demonstration Area, or FERDA, just to the north in the Adirondacks. This was implemented by Mark Tweary during his time with the Forest Service. And then, of course, the Bartlett Experimental Forest, which Bill Leake and Mariko Yamasaki made famous. And if you've had an opportunity to work with long-term data of any variety, you know that it comes with some quirks. So I want to make sure that I acknowledge those. I'm going to start first with Huntington. Prior to the establishment of the experiments here, this was classified as mature northern hardwood, but because of practices in the area at the time or prior to initiation of the study, there had been some selective spruce harvesting. We're looking at 3 single tree selection stands here. There are a variety of silvicultural treatments going on at Huntington, but we're going to key in on a couple. Ralph was a big fan of the Arbogast guide, so he used that structural guidance when laying out the single tree selections in the 1980s. And he also had the wherewithal to recognize there was a lot of beech here. So prior to harvesting, there was herbicide application. That's really important. We also were interested in a uniform shelterwood stand here at Huntington. This was started in 1968. They went in and removed approximately 50% of the basal area in the establishment cut, took the overwood off about 10 years later, and again, killed the beech prior to that establishment cut in an effort to give those species a chance to get started. They also were really cognizant of the high deer population here. So since the 1960s, reducing deer has been a part of the overall forest management plan. And for us in the Northeast, this is considered a decently productive site. So well-drained, loamy soils. Just to the north is that FERDA site. This is managed by Paul Smith and again, Mark Tweary. Here we're looking at single tree and group selection. Instead of the Arbogast guide, Mark chose Q factors of 1.3 and 1.4, a uniform shelterwood. The establishment cut was a little heavier here, reducing 70% of the volume by basal area, and then the overwood came off 16 years later, and then a clear cut, which basically took out everything. This was started in 1998, and the soils are a little more poor here. So these are excessively drained, loamy, fine sands. No intentional effort to reduce beech, no intentional effort to reduce deer populations. And then last, but certainly not least, is the Bartlett Experimental Forest. So here again, this was mature northern hardwood with an irregular structure at the time. There had also been some selective removal of softwoods, but more of the hemlock variety. We're looking at 3 single tree selection stands here. These were implemented with a Q factor in the 1950s. Then we have 2 group selection stands that were started in the 1930s and 40s. Bill, however, chose to use area-based control rather than a Q factor. And then 1 uniform shelterwood, which was started in 1999. Prior to that, the stand had been treated with single tree selection, but when they went in to do the establishment cut, they took out about 50% of the basal area. This is a well-drained till soil. So there's a lot of noise, if you will, in this data, and I'm going to try and synthesize that around 3 key characteristics when we're considering site. So the first would be site productivity, and you can think about these stands on a gradient. Huntington would be the most productive, working your way down to FERDA, and then Bartlett would be the least productive, at least in terms of soil properties. If we think about beech control, remember that was only an intentional part of the management at Huntington. It doesn't mean that there wasn't some sporadic use of herbicide, the other studies over time, but this was part of the silvicultural prescription right out of the gate in Huntington. And same with deer management. Continuous effort to reduce those deer numbers. So when we think about our objectives, acknowledging that there's a lot of distinction from site to site, is it even possible to tease out some trends of these commonly applied silvicultural systems across this region when we think about things like structure, composition, and regeneration, which are often the benchmarks we use when trying to decide if a silvicultural system has been quote-unquote successful? And some trends are obvious. Some are things that we would expect. For example, we know that structure is a really critical piece, especially of our uneven age systems. We often throw around the term of the reverse J, and we saw that that was achieved almost across the board, even early on. So our FERDA is our shortest, if you will, of the long-term studies. And what we're looking at here, here we go, okay. What we're looking at here is the pre-treatment data from the single tree selection stand. On the y-axis, you have density, and on the x-axis, you have diameter classes, so pretty jagged in the beginning. And within 20 years, moves towards that reverse J shape that we associate with our uneven age stands. So that was an expected result. Similarly, we saw that species structural diversity decreases in our even age stands. We're focusing on maintaining 1, maybe 2 age classes here, and so that's not surprising. But where things really start to get sticky is when we think about composition underlying that structure. And so we saw pieces again that we would anticipate. Do you want to maintain more shade intolerant species? Then you probably need more canopy disturbance. However, where I at least maybe started to feel disheartened is when I looked at some of the data specific to Huntington. So I apologize because I've shifted units on you, but the idea is the same. We have density here and here. On the left, we're looking at pre-treatment data, and on the right, we're looking at post. So this is a stand treated with single tree selection, and what I want to draw your attention to are the colored bars that make up the cumulative stand structure, which is represented here in the black, particularly this red line. So that's American beech. And remember, here is a place that they had done herbicide application. They had tried to reduce the deer numbers. And we're still seeing, especially in these smaller diameter classes, what's driving that structure is beech. Yeah. And again, this is a really beachy place. If you remember that heat map for American beech, we're smack dab in the middle. So what about regeneration? What are our options here? What are we seeing? The good news, these forests want to regenerate. There is ample regeneration here. They want to be growing trees, so that's great. When we have specific goals in terms of species composition, that's where we need to be really thoughtful. Larger openings, generally speaking, increased the composition of other species, whereas when our openings were small, almost always, across sites, across treatments, we saw that these were beech stands. So some data, these aren't all the treatments, but just to cherry pick and convey the point, I suppose. If we start at the top, this is post-treatment data of regeneration, and we're looking at the 3 single tree selection stands here from Huntington, and what we saw is that over time, all of them increased in beech density, every single one. If we look at the Furta single tree selection, same thing, beech went up, and even Bartlett, the group selection where those openings might be larger, we still saw that the density of American beech increased over time. So across time, treatment, space, we're seeing that beech is really doing well here in the regeneration size classes. And that would be one thing, but what concerns me more is that there aren't really a lot of other species that are making up this regeneration size class. So it might be okay if we had a lot of beech, but we had other species. We're just not seeing that. There are some degrees of difference, but we're really not seeing that, with the exception, maybe, of some sugar maple at Huntington. Okay, what if we think about our even age treatments where we had those larger canopy disturbances? This is where things start to look a little bit better. So in the clear cut at Furta, we see that beech decreased over time. What about the shelterwood at Huntington? It doesn't decrease, but it stays the same. So I'll take that. That seems like a win. And I also noticed that there are other species that are present here. So again, it just feels like we have a few more options. So with all of this in mind, what can we take away? Whenever I work with studies like this, I'm incredibly humbled and reminded that the forest often does what the forest wants to do. And I might have a great idea, and sometimes it works and sometimes it doesn't, but the forest tends to do what the forest wants to do. However, we can maintain a range of size classes, and we can maintain different species and ample regeneration across the northern hardwood forest with these methods that we've been trying for a long time, which have value when we think about things like climate change. We know that having a range of size classes is important. We know that as markets shift, having a range of species is important, and we're able to do that to some degree. We just have to be careful. If we have specific compositional goals that we're trying to hit, beech is really, really persistent here and does a great job of growing. The other thing that has been on my mind anyway, at least in the last year or two, and who knows what that will mean for these results, we have a lot of beech leaf disease in Maine now, and it's really doing a number on the beech trees. And so I don't know what that's going to mean in these stands that have been so heavy to beech in the past. Does this mean that sugar maple will be able to make a comeback? I'm just not sure. But it reminds me that when we're thinking about silviculture, we need to be very cognizant of what's going on at the site, because it can be so different from place to place, and that we also need to take a long-term view. So Laura's quote of silviculture matters, I really like that a lot. And I would say that silviculture matters in the long term. So it can't just be I went in and I did one cut, I did one herbicide application, I killed one deer, right? It has to be this long-term goal. Okay, with that, thank you very much.
Thank you very much, Dr. Rogers. Any questions for Nicole?
What I'm wondering is what was interesting to me, particularly from a maritime context, it's similar to Maine, despite the herbicide application at Huntington, is it Huntington?
Yep.
You've still got more beach response. What's the moisture gradient like across those sites? Like because at least what I've noticed in the Maritimes is that there's not only a fertility relationship
Yep.
with beech and sugar maple, but also moisture stress.
Yep.
In the heat of the summer, like I particularly see it in New Brunswick as opposed to
Yep.
Nova Scotia. Like do you think there's a moisture regime interplay, particularly during the growing season, that may favor beech over sugar maple?
Yeah, I think there could be. And if we look, some of the work by Charlie Cogbill showing the historical ranges of species prior to American colonization, we see that beech was really prevalent there before we ever showed up here. And so there's something about those places that beech wants to be. Part of it could be the moisture. We did see a difference in soil moisture between Huntington and Ferda, which is just to the north. Ferda is more dry. The other thing I think going on there is that was herbicide applied once, and it had been 25 to 30 years. I suspect if we had come back in, been able to apply it again, initiate that next harvest, maybe we would see some results that buys us some more time, but I think we're at the end of the window of effectiveness. Yeah.
Okay, thanks, Nicole. Nice presentation. You showed data at the end on stem density. I was wondering if you had any information about the height of the regeneration, because at some places there was yellow birch,
Yeah.
maybe not as much as beech, but because in the absence of browsing, we see sometimes that the yellow birch can outcompete beech, even though there's more beech.
Yes, yep, that's a great point. So we do have data on height. It's not broken down here. This would be what we would consider the more established regeneration, so not the little tiny seedlings, but things that have made it past at least that 1 foot threshold. However, we do have that broken down further into size classes all the way up, well, it would be less than an inch in diameter and whatever height that may achieve. So we could look at that next and see if there's a distinction and a drop-off.
Thanks. I thought I'd just ask you to push your conclusions just a little bit further.
Sure.
Based on your findings and your framework of site productivity and site conditions, what are maybe some new recommendations for what silvicultural systems we apply where, what we should watch out for?
That's a crisis of faith I have every fall when I teach my students. I don't know. That's the short answer. I am intrigued by work by folks like Patricia and Steve looking at irregular shelter woods. I like the flexibility that offers, but I'm not ready to step away from these either. I think conditions change well beyond the time step that humans are able to envision, and so I still want to know what these systems can look like. It'll be beyond my career, but I'm still interested in seeing how these can play out over time. I think it's going to be more intervention regularly, especially in the life of a regeneration method. That's what I'm seeing. I don't think it's going to be as simple as I have my regeneration method and I come back every 20 or 25 years and things get me what I want. I think there's going to have to be more strategic work in between those windows of time, regardless of what method you choose to employ. And diversity across the landscape, not just one system, multiple systems across the forest, because we just don't know where things are going yet.
Thank you.
Great.
Token appreciation for your contribution. Thank you very much. It's good to have you.
Yeah, thank you.